Hey everyone, welcome back to another LeetCode problem solving video. Today we are cracking LeetCode 202 happy number. The problem defines a happy number, a number where if you repeatedly replace it with the sum of squares of its digits, the number eventually collapses down to exactly 1. If it reaches 1, it stays 1 forever and it's a happy number. But what if it's not a happy number? It's unhappy. The numbers will loop endlessly in a cycle and never reach 1. Our goal is to determine whether a given number is happy or caught in an endless cycle. Let's first talk about a clever strategy to catch this loop, and then we will jump straight into the code. Now, before we write the code, let's talk about the secret trick to solving this problem in constant space. If a number is not happy, it enters an infinite cycle. If you map out this cycle mathematically, you will discover a fascinating pattern. Every single unhappy sequence eventually traps itself in a loop that contains the number 4. Because of this mathematical certainty, we don't need to use a heavy hash set to track every number we have seen before to detect a cycle. Instead, our approach is brilliantly simple. We will repeatedly extract the digits of our number, square them, and add them together. We wrap them, we wrap this in a loop that continues as long as our number has not become 1, which means it's happy, and has not become 4, which means it's caught in the unhappy loop. The moment the number hits either 1 or 4, the loop breaks. We then simply check if the final number is 1. If it is, we return true, otherwise false. Let's see how beautifully this translates into C++ code block by block. To start, we declare our function isHappy, which takes an integer n. We immediately set up our master while loop. This loop acts as our cycle detector, continuing to execute as long as n is not equal to 1 and n is not equal to 4. So let's do that while n not equals to 1 and n not equals to 4. So inside this loop, we are ready to calculate the sum of the squares of the digits for the current number. We initialize a temporary integer tracker called sum to 0. So let's initialize it in sum equals to 0. Now next we set up a nested inner while loop that runs as long as n is greater than 0. This loop is our standard digit extraction engine. Inside, we isolate the last digit of the number by using modulo operator and modulus 10. We multiply this digit by itself to square it and add it to our running sum and then chop off the last digit of n by performing integer division n by 10. This loop runs until every single digit of n has been processed. So let's do that. So while n less than 0 and greater than 0, 8 digit equals to n modulo 10. Sum will be equals to sum plus digit multiplied by digit. Okay, and n will be equals to n divided by 10. Once the inner loop completes and all digits are extracted, our sum holds the new squared total. We assign this sum back to our variable n. The master loop will now evaluate the new value of n in the next iteration. N equals to sum. Eventually, n will either hit 1 or 4, causing the master loop to determine. At the very end, we return the Boolean result of the expression n equals 1. If n ended up as 1, it's true. If it is trapped itself at 4, it returns false. So we will return n equals 1. Okay, now let's run and check whether it is passing the base test cases or not. Okay, so it's perfectly working for the best test cases. Now let's move towards the dry run. Now let's take a number n equals to 19. Now the master iteration one, we check the condition is 19 not equals to 1 and 19 not equals to 4. Yes, both are true. Loop enters. Sum is initialized to 0. Inner loop processes 19. Extract 9. Sum equals to 0 plus 9 into 9 equals to 81 and becomes 1. Extract 1. Sum equals to 81 plus 1 into 1 equals to 82 and becomes 0. Inner loop finishes and is updated to sum. So n equals to 82. Now in second iteration is 82 not equals to 1 and 82 not equals to 4. Yes, loop enters. Inner loop processes 82. Extract 2 sum equals to 0 plus 4 equals to 4 and becomes 8. Extract 8 sum equals to 4 plus 64 equals to 68 and becomes 0 and is updated to sum. So n equals to 68. Now in fourth iteration is 100. Sorry. Now in third iteration is 68 not equals to 1 and 68 not equals to 4. Yes, loop enters. Inner loop processes 68, 6 square plus 8 square, 36 plus 64, 100 and is updated to sum. So n equals to 100. Now in fourth iteration is 100 not equals to 1 and not equals to 4. Yes, loop enters. Inner loop processes 100, 1 square plus 0 square plus 0 square equals to 1 and is updated to sum. So n equals to 1. Now the master loop checks the condition again. Is 1 not equals to 1? That is false. The loop instantly terminates. The function executes return n equals 1, which evaluates to true. 19 is officially a happy number. Now let's submit and check whether it is passing all other test cases or not. Yes, so it is perfectly passing all the other test cases. Now let's quickly discuss about the complexities. So the time complexity for any number, the sum of the square of its digit drops very quickly. For example, any number above 1000 will quickly shrink down to into smaller digit spaces. Once a number drops below 243, it either cascades directly to 1 or gets trapped in the cycle of length 8 because the path length to reach 1 or 4 is bounded by a small constant value. The time complexity is effectively logarithmic, which is order of log n, matching the number of digits in the integer. The space complexity. Now take a close look at our variables. We aren't creating any vectors, arrays, or auxiliary hash sets to track string numbers because we rely on the hardcode cycle marker 4. We are only using a few primitive integer trackers, some digit, giving us a perfect constant space complexity of order of 1. And this is all about space and time complexity. And that is how you solve the happy number problem with maximum efficiency, leveraging the mathematical fact that all unhappy numbers cycle through 4 allows you to completely bypass allocating extra memory. If this block breakdown and dry run has the logic click for you, make sure to slam that like button, subscribe to the channel for more code walkthroughs, and let me know if you have any kind of doubt in this solution. Keep grinding those problems, and I will see you in the next video.